I'd like to bring up Dave Meurer from Synopsys, who's actually got a great talk, really interesting and I think pertinent talk. We talked about, when we experience this personally at Verizon right now, as we make that transition from closed source to open source, it opens up all these new avenues for risk. So how do you appropriately manage that new open source software risk? So give it up for Dave, please.
Thanks, Josh. Well, I tell you, it's I do a lot of talks, but it's rare that I get to talk to folks, my people from my own backyard. So I'm very excited to be here. I'm a local. I'm not a native. Not a native. How many natives do we have? Floridians. There's 1, 2, 3. That's actually more than I expected because, you know, most of us are from up north, and I tell my northern friends that even though you don't live in Florida, you will eventually, right? So I'm Dave Meurer. I actually started my career across the Bay, worked for Accenture for 7-8 years, then wanted to be on the TV screen, so I became a web developer at Home Shopping Network. But then after that, my open source career started. So I worked for a startup company that did application Spring generation, and then moved into open source risk management with a company called Black Duck Software. And I've been with Black Duck for 8 years now. Black Duck was acquired by Synopsys a year and a half ago. So what I wanted to talk to you today was about open source software and the risks associated with managing open source. And you know, as you think about DevOps, that's one of the things Synopsys is attempting to do with our customers is help to put that quality and security in DevOps as you take that journey. So let me start off. Why not start a lunch talk off with a food label? I didn't do this on purpose, but it sort of worked out that way. But this talks about how modern software is built today from an application standpoint. So if you think about everything that composes an application, you've got your own code that you write, your own proprietary code. Then you've got the stuff that you bring in, the binaries, the open source components. You might be using some APIs, and there might be some configs as well. So it's sort of a combination. It's just not code that you write. And unless you're spending hours and hours of writing your own code, you're going to be at one point using open source software. This slide really talks about, it's not a dig on commercial software or open source software. There's some great commercial software out there. There's some great open source software. There's some bad commercial software. There's some bad open source software. So it's all about how you manage the software that you bring in into your DevOps. And with open source, there's really 3 categories that you need to manage when you're bringing it in. One is obviously security risk. Security risk are things like known vulnerabilities, and we'll talk more about that. There is a component to open source software that poses legal risk. If you're familiar with licenses like the GPL license has obligations that say if you distribute your code and you're using open source software, you have to open source your own proprietary code, right? So folks like who create cell phones or routers or TVs have to worry about that, and there's been some legal cases in the past involving open source software licensing. And then there's operational risks, so things like how old is this open source component, what's the community around it, right? Because if a security vulnerability happens in an open source software component, you want to ensure you have a vibrant community that patches things quickly. So one of the things I want to talk to you about is a free resource. You can go out to the internet and download it. Synopsys puts this out. It's called the Open Source Security and Risk Analysis. So through the Black Duck acquisition, we've been doing this for about 4 years. And it's a anonymized and aggregated booklet of open source stats taken from actual applications that we've analyzed. Now, these applications are typically in a merger and acquisition type of aspect. So, Black Duck's tooling is analyzing these applications that are going to be acquired. And then, we've got this data that we anonymize and put out what we call the state of open source software. So this is actual applications. And the industries from these applications range, as you can see, from enterprise software all the way to energy. And really what this slide is saying that, all the 1,200 applications that we analyzed, every company now is a software company, whether, they think they are or not. So to jump into some of the stats, one thing I want you to remember is, as I mentioned, these are companies that are acquiring software assets that we're scanning. So those software applications that are being built tend to be more proprietary than they would, sort of if it's an application that you're supporting an IT function. So these stats are actually a little bit more conservative than what you would see normally on average out there from an entire application perspective. So 96% is the number of code bases. There were 96% of those applications that had open source. And the interesting thing about that stat is there was a handful of applications that we audited that had 1,000 lines or less of code. When you take those out, that number becomes 99%, which basically means everybody's using open source, right? The 60% statistic is that that is how much open source of that code base was. So if you take, Apache Struts, it has 50 million lines of code, and then all of your proprietary lines of code. That's basically saying that over half of your application is open source code. Last year, it reached the over 50% mark, with a 57%. Before that, it was only a third of the entire code base was open source. So there's been a dramatic increase in the amount of open source software code that's been found in your applications. And then the 36%, the third of code bases that we found had more than 50% of their code being open source. Now, if you think, don't disagree with those numbers, I challenge you to go back and look at some of your applications and list how many open source software components you find. That's what we typically do when we go to these companies. Say, hey, give us your list. And what happens is they tend to only give us about half of what they actually have after we do a scan. So you can see there's about 300 on average open source components found in these code bases. But it's really tough to find those open source components because when you could say, hey, yeah, I'm using Spring, but when you start to build with Spring, it brings in 11 other open source components that might depend on 11 other components, right? So there's a dependency tree there that you may not be aware of. I mentioned licensing. So this is a stat in terms of license conflicts that we found. License conflicts is based on how you're distributing your application and how you're using that component. So we found that 68% of the code bases that we've built had license conflicts. So a GPL license was found in an application that was distributed, or somebody took code from an LGPL, the lesser GPL, and embedded it in their code. That's a license conflict because that's not the intended way of usage unless you want to open source your own code. And then you can see there 61% contained that type of GPL, the copyleft type of licenses that we found in applications. Now, the interesting thing that licensing and the types of licenses have evolved actually for the better over the last decade. So, we know about 2,600 different licenses. If you're in this industry, you won't go a day without hearing about the beer license, which is a very much pervasive license. It's basically 2 lines by this guy, Peter. He's got a Swedish last name, but the obligation is, you can use this code as much as you want, but if you find me in a bar, you have to buy me a beer, which is a pretty cool license. I actually created my own pizza license because I love pizzas. So if you use my license, you have to buy me a pizza. And so there's all these different types of licenses, but the good news is that over the last 2 or 3 years, the the usage in licenses has condensed. So we've seen that the top 20 licenses that we've found are used now in over 98% of the cases that we identify. So that's a good thing. Now, obviously, open source, one of the main reasons you want to use open source is to reuse that code. But the key thing about open source is staying on top of it, staying on top of the versions. You can see here 85% of the components that we found were 4 years old. On average, we're finding components more than 10 years old as well. The interesting thing here is that if you don't stay on top of your versions, that's when security vulnerabilities start to creep in. Because, typically a new version is revved, a new point version is revved to address or patch a security vulnerability. And you can see the list, top 10 components that we found. At the top of that list was jQuery, and what you don't see here is the most popular vulnerability that we found. CVE 2012-6708 was a jQuery vulnerability. So the most component was found was jQuery, and the top vulnerability was found was based on a jQuery vulnerability as well. So the point here is you got to stay on top of your open source versioning in order to stay on top of the patches. Speaking of security vulnerabilities, this bar chart is taken from the National Vulnerability Database. If you're not familiar with National Vulnerability Database, is a public entity that publishes vulnerability information on software. It publishes these things called CVEs, Common Vulnerabilities and Exposures. And you can see over the last 2 years the huge jump in the number of vulnerabilities that have been published. And so trying to stay on top of your open source components, as well as all the vulnerabilities that have been published from a manual perspective, is obviously very difficult. We found that over 60% of the applications that we audited in these 1,200 applications had vulnerabilities, and almost half of them had 40%, or almost half of them had high-risk vulnerabilities, critical vulnerabilities. The good news here is that 60% that you see is trending downward. So last year's report was actually 78% of the code bases had vulnerabilities as well. So that's good news. Now, one of the more interesting vulnerabilities we found was this gem. So this is probably older than some of you out there. This is CV 2000-0388. It's a almost 30-year-old vulnerability that we found and in our applications, buffer overflow for Termcat. But the interesting thing is, 43%, almost half of the vulnerabilities we found were over 10 years old. On average, the vulnerabilities found were about 6.6 years old. And I'll dissect a vulnerability here in a second to kind of help you understand how the vulnerability process works. And we'll talk about that now. So this is one of my favorite components, not to use, but to demo. Apache Struts, as probably known, has been in the news over the last couple of years. I want to talk about this CVE 2018-11776 and just go over how these vulnerabilities surface themselves and what the process is. So on August 21st, this was 2017, this was reported by a responsible security researcher. Mr. Man, you Mo. And on the same day, Apache was available. Actually, it was disclosed and reported by the Apache Struts Foundation. Now, patches aren't built in a day, so what happens is there is an embargo process that occurs where the security researcher notifies the project or the application owner and works with them to create a patch before publishing it out, to the masses. And that happened, a couple weeks beforehand. Now, interestingly, this vulnerability wasn't known, but it was introduced, you could see, about 10 years earlier, in February 2007. That's the typical thing we see with open source vulnerabilities, is that are introduced well beyond when they're found. So this very next day, a CVE number came out, just the number. You see the word Black Duck Security Advisory. So Black Duck produces a lot of information as well, full details on vulnerabilities the day of. But the problem is that the public information you see typically looks like this for a couple weeks when a vulnerability is published. You can see the vulnerability is currently awaiting analysis. And there's a description, but the tie into the actual product and the rating really doesn't come out for a couple days, or on average a couple weeks. And even some of the versions aren't accurate, so there's other versions that are discovered later when this vulnerability is published as well. So that's something to think of. In this specific case, the National Vulnerability Database didn't publish information until August, September, November, a couple months later. So they had obviously they had the number, but then they declared the CPE, which is the product enumeration, which ties this vulnerability to the actual product, in this case, Apache Struts 237. CVSS scores, which are high, medium, and low, basically. And then the CWE, which is a category. It's like this is a SQL injection, or different categories of security vulnerabilities. So of course, your area of vulnerability is not November 1st. It's when that vulnerability is published. So that's one thing. You got to stay tuned to things that are published. Search other places than what the National Vulnerability Database provides. Now, I wanted to go into some trends around open source tooling. If you ever want to look at managing your open source in an automated fashion, I just wanted to go over some of the trends that I've seen over the last 8 years, to help any sort of evaluations that you're going through. It all started around license risk in technology companies, and it's still very prevalent today. So companies that distributed software on routers or cell phones, and they were very much concerned about, hey, what am I using from an open source perspective, because there were some major lawsuits that occurred, several years ago. Then security risk. Security risk wasn't a big factor back in 2003, but around 2014, some creative people started naming vulnerabilities like Heartbleed. I'm sure you've heard of Heartbleed. There's others been like Shell Shock and Poodle, Ghost, Venom, and trademarking like logos and things like that. And the dates are kind of messed up here, but around 2014, that's when we saw sort of a transition of focus in open source tooling, management tooling around security vulnerabilities. Licensing is obviously still key, but security has sort of taken over. And there's been really 3 categories of evolution in open source tooling from my perspective. One is how you identify that open source software. Back in the olden days in 2003, it used to be, you'd have a scan, but you'd have to do a lot of manual work. Because one of the problems with open source is that open source uses itself constantly, right? So there are 300 forks of OpenSSL. And if you scan one application, you'll find embedded OpenSSL program functions and files in other applications as well. So it was very difficult to automate the identification of open source and say, hey, yeah, this is where you actually got this open source software from. And so you would be presented with a list of all possible matches, and you'd have to click the right match. Well, that's evolved over the last several years. Algorithms and techniques have been augmented to automate the discovery of open source software, which has been very cool to see. And the numbers are, and the second thing is really enhanced vulnerability data. So we talked about what the National Vulnerability Database provides, but it doesn't really provide actionable information, right? You don't know what to do. Should you patch this vulnerability? Is there a workaround? Where in the code is this vulnerable? So you can kind of see what commit actually, created this vulnerable code. So you've seen a more of an enhanced vulnerability metadata come out in open source tooling as well. And then the third thing is really workflow. So how do you manage the flow of open source within your DevOps, within your SDLC? And back in the day, people wanted custom workflow tools to have approval processes for open source software. But companies quickly realized that slowed developers down. Developers hated that idea. Why would I have to submit a form for me to use Apache Struts and all of its transitive dependencies when I can just download it and you can just scan it and tell me the answer? So that's where it's evolved to. It's let the developers develop, let the build occur, and then provide gating features and policies around your threshold for open source risk in DevOps, in your pipelines. And so those are the three, I would say, features that have evolved, over the past several years. Now, talking about identification techniques, there's really four major algorithms in my mind that you want to look for as well. There's one called what we call build process monitoring. It's really the declarative side of things. So if you think about programming languages like Java or Node, they tend to have package management systems. Even Linux has package managers where components are initially declared. So in my POM file or in my Gradle file, I want to use Spring Framework 3.1.2, right? And then the build determines, yes, okay, I'll use that version. It needs these dependencies. Does another component need a different version of Spring? And so the build figures all that out. And you can attach yourself to that build process monitoring. You can pull those IDs out and say, okay, yeah, you've declared this. There's a little bit of an issue there. If you're a developer and you're declaring your open source software, that doesn't necessarily mean that specific version will end up in your build, because the build can then decide, as I mentioned, what actual version to put into that application. So you kind of have to be careful with those declarative type identification techniques. They're fast, very fast, and they're very useful for like when you're developing in an IDE or things like that, but they could provide the wrong answers. So you need some sort of file system scanning. That's the second piece there, or evidence-based, where it's looking at the actual application or the files on disk and tells you the answer. It says, hey, this file or these set of files is this version, because version is everything when you're managing open source software. It tells you the license, it tells you the security vulnerabilities. There's also the idea of code snippet matching within open source. And this is very important for legal folks in the licensing part. It's not so important in a security sense. But it's basically telling or letting you know that this code was actually borrowed from open source software. It's totally fine. You can absolutely do that. But if you borrow code from open source software, you have to ensure that that license of that open source project allows you or has specific obligations you have to worry about. Like I've mentioned in the router example. And that happened. If you have an old Linksys router, you may be able to go into the Cisco website, download some code, and make that Linksys router a much more powerful router, because they were involved in a lawsuit, which was very complicated, but that had a GPL license in it. So that's essentially code snippet matching, showing you what code has been borrowed from open source software. Then there's more enhanced binary analysis. So, you can do file system scanning, but if your scanner can't understand binaries or crack into binaries to find open source software, you're leaving a big part of your application suite, outside of this management piece. So being able to not only look at jars and wars, zip files, archive files, but also things like executables or firmware, and find the open source software in there. So if you have a supply chain that you have your customers bring in their executables to you, and you say, hey, can you give me a list of open source software? They'll provide you a list. And if they're doing it from a manual perspective, that's probably half of what they actually have, as we talked about before. So you want to be able to scan those to verify, right? Trust but verify. And then there's optimal points to apply that scan. So this is not to say that you need to add open source scanning in every single stage of DevOps. This just says that each use case has different features, and you should look at the possibility of integrating within what makes sense for you. By far, the most popular integration point is continuous integration, because the build is that point where you know the answer, what this application will be, and you can get the answer very quickly. It's obviously moving left to the developer, so you also want developers to be in charge of open source and the security and licenses risk. It's a very important point. So you want to make sure you have things like IDE plugins that can tell developers the answer right away, so when they go to push their changes and the build happens, they won't be surprised with any issues or with any failures. But as you move into DevOps and containers now present a larger issue, because containers are, essentially most of them are Linux, right? And Linux is made up of a lot of open source components. Your typical application is only a third, maybe even a lot less than your container in terms of how many open source software components exist. So when you're deploying your images, you got to ensure that that image comes from a trusted source, and that they're patching those open source components, and that you know what open source components are in those containers. Think about all the GNU, lib components that's in a Linux distribution, OpenSSL. So as you're deploying or as you're managing those images in your registries, that's another integration point that's gaining more popularity in terms of finding that open source software. All right. So to close, the key takeaway in all of this is it's really difficult to manage your open source software from a manual perspective. You are using open source software. It'd be a good idea to manage those, identify those, get them in some sort of program. Because if you're building modern applications, you're at a DevOps conference, and I know you are, you got to be ensuring that you're managing that open source software. Get your developers involved with open source. They're really the key to governance. I would say 15 years ago, developers hated these open source tools because they slowed them down. But as the tooling has evolved, we're getting developers a lot more interested, enthusiastic about some of the IDE plugins that you see out there, some of the tools that you see out there, so that they can build better code and more secure code. And then just one point about communities, right? Engage with open source communities. That's how open source is built. And if you look at some of the great projects out there, they've got really vibrant and welcoming communities. So feel free, if you're using an open source component, let the community know about it, get involved, write issues, They absolutely want to hear about it because that's how open source grows. That's it. If you have any questions or any things you want to discuss, I'll be around. We have a booth in the expo hall, and I really appreciate your time during this lunch hour. Thanks, everyone.